NASA's Pilgrim 1 spacecraft, which currently holds the record for the farthest distance traveled by any human-made object, has fascinated people across the globe for nearly 50 years. Since its launch, Voyager 1 has relayed vital data from the furthest parts of space, expanding humanity's understanding of the universe. However, the spacecraft's ongoing transmissions have recently faced strange anomalies that have left scientists puzzled. These mysterious signals have ignited intense discussion, making the scientific community question 33 seconds whether these anomalies are simple malfunctions or signs of something much more extraordinary, possibly even extraterrestrial activity. Join us as we investigate these puzzling signals and explore what could lie hidden in the vastness of space. The human desire to discover the unknown has always been the driving force behind space exploration. This deep-rooted curiosity led to the development of ambitious missions like Pioneer 1 and Explorer 2, which were among the most daring space missions of their respective times. On August 2, 1 minute and 5 seconds 1977, the launch of Explorer 2 from NASA's Kennedy Space Center marked the beginning of a transformative period in space exploration. Shortly afterward, on September 5, 1977, Explorer 1 was launched, setting off on a path that would eventually take it toward the outer planets, significantly altering its orbit and the outcomes of its mission. These two spacecraft, each weighing approximately 720 kilograms, about the size of a small car, traveled in separate directions at varying speeds. On December 15, 1977, a key milestone was achieved. 1 minute and 42 seconds when Explorer 1 surpassed its twin in distance traveled due to the different routes they followed. Since that time, Explorer 1 has proven to be an invaluable tool in broadening our understanding of the universe, offering insights that have transformed how we perceive space. Before we delve into some of its recent groundbreaking discoveries, let's first review some of its earlier major achievements. In 1978, while situated around 265 million kilometers from Earth, Explorer 1 successfully captured detailed imagery of Jupiter. By January 2 minutes and 16 seconds 1979, the spacecraft had completed a remarkable 100-hour mission, producing a time-lapse video that showcased the rotation of Jupiter. This series of 3,750 images provided unprecedented views of Jupiter's chaotic atmosphere and intricate features. During this mission, the spacecraft also discovered a previously unknown ring encircling Jupiter and identified 2 new moons, significantly enhancing our understanding of the gas giant's complex system. To ensure its safe journey and avoid potential collisions with Titan, 2 minutes and 50 seconds, one of Saturn's moons, the spacecraft performed a series of correction maneuvers. Following this, the focus of the mission shifted beyond our solar system's planets as the spacecraft was redirected toward interstellar space, traveling at an astounding rate of 325 million kilometers per year. In January 1990, Explorer 1 embarked on its mission to explore interstellar space, continuing its journey beyond the solar system. During this phase, the spacecraft achieved several remarkable milestones, including the discovery of 3 minutes and 23 seconds additional moons, Mimas, Enceladus, Tethys, and Rhea, and capturing some of the most iconic images of our solar system's outer regions. On February 14, 1990, at a distance of about 6 billion kilometers from the Sun, Explorer 1 took its famous family portrait, capturing stunning photographs of the inner planets. This collection of 60 images joined the spacecraft's portfolio, which also included 670 images taken during its flyby of Neptune. Explorer 2, meanwhile, also achieved impressive milestones during its mission. It recorded wind speeds that exceeded 3 minutes and 59 seconds 13,100 meters per second, the fastest winds ever recorded in the solar system, providing scientists with essential data on Neptune's distant atmosphere and its moon, Triton. Triton, which has surface temperatures that plunge to a frigid minus 391 degrees Fahrenheit, is one of the coldest places in the solar system. It also displayed ice volcanoes ejecting nitrogen gas and frozen particles up to 5 kilometers high, offering an exciting new perspective on the moon's features. These extraordinary discoveries have greatly expanded our understanding of the 4 minutes and 33 seconds diverse and dynamic environments in the outer reaches of the solar system. The contributions of both Explorer 1 and Explorer 2 have been nothing short of groundbreaking. Their missions uncovered previously unknown details about the moons of Jupiter and Saturn, which had previously been thought to be dormant. These findings reshaped our understanding of the geologically active nature of these moons. In particular, Explorer 2 made history by becoming the first spacecraft to fly by both Uranus and Neptune, an achievement that has yet 5 minutes and 5 seconds to be repeated. NASA employed a variety of innovative strategies to extend the missions of these pioneering spacecraft, such as shutting down non-essential systems to conserve power. The mission is expected to continue until 2030, marking the end of an era for the engineers and researchers who have dedicated themselves to this extraordinary journey. And so on. As Explorer 1 and Explorer 2 ventured deeper into interstellar space, their instruments continued to record strange anomalies, unexpected fluctuations in magnetic fields, unusual bursts of radiation, and signals that seem to defy known cosmic patterns. At NASA's Deep Space Network, scientists tirelessly analyzed the transmissions, searching for explanations. The anomalies did not resemble any previously observed cosmic phenomena, nor did they align with known technical malfunctions. The signals, seemingly structured, arrived at irregular intervals, almost as if they were part of a complex pattern waiting to be deciphered. 18 minutes and 12 seconds. Dr. Elaine Carter, an astrophysicist leading the mission's deep space monitoring team, sat in front of a massive data display, her fingers hovering over the keyboard. "This isn't just random noise," she muttered. "There's something intelligent about it." Her team exchanged nervous glances. The thought had crossed all their minds, but no one dared to say it aloud. Could these signals be of extraterrestrial origin? A deeper analysis revealed an astonishing discovery. Each burst of radiation contained repeating frequencies spaced at mathematically significant intervals, almost like a coded message. The structure of these signals resembled prime number sequences, a concept that, if artificially generated, would indicate an advanced intelligence at work. 18 minutes and 55 seconds. News of the discovery spread quickly, sparking debates among scientists, government officials, and even the public. Was this the first definitive sign of extraterrestrial communication? Could it be a natural cosmic phenomenon yet to be understood? Meanwhile, Explorer 1, continuing its voyage beyond the heliopause, recorded an even more perplexing event. On March 3, 2025, its sensors detected an abrupt shift in interstellar plasma density, so extreme that it suggested the spacecraft had crossed into an entirely new region of space, unlike anything observed before. "This doesn't match any existing models," said Dr. Carter, reviewing the data. "It's as if the spacecraft has entered a void, or a corridor." 19 minutes and 30 seconds. For the first time in history, the boundaries of known space seem to be shifting. NASA prepared a special transmission. Using Explorer 1's remaining functional systems, they would attempt to respond to the anomalies, sending a carefully encoded reply in the form of a simple mathematical pattern. If these signals were artificial, perhaps whoever, or whatever, sent them would recognize the response. As the transmission was sent, all they could do was wait. And then, the unexpected happened. At 20 minutes and 15 seconds, an entirely new signal arrived. Unlike the previous bursts, this one was clear, direct, and undeniable. A repeating sequence of 3 pulses, followed by a pause, and then a single pulse in return. Humanity had reached into the void. And something had answered. The control room at NASA's Deep Space Network fell into stunned silence. The repeating pulses on the screen, 3 bursts, a pause, then a single pulse, played back in an eerie rhythm, unlike anything encountered before. Dr. Carter's hands trembled as she hit the replay button. This isn't random," she whispered. "It's a direct response." The realization sent a wave of excitement and fear through the team. For decades, humanity had searched for signs of intelligent life beyond Earth, sending messages into the cosmos with the faintest hope of a reply. Now, Explorer 1, a 50-year-old spacecraft, might have just made first contact. 21 minutes and 12 seconds. The transmission was analyzed frame by frame. The timing, the spacing, everything about it suggested intent. But was it a greeting? A warning? A simple acknowledgement? Could it be a reflection of our own signal? One of the engineers asked, trying to remain skeptical. Dr. Carter shook her head. "No, we accounted for that. There's no natural way for the response to return in this pattern without intelligent intervention." A new possibility arose. What if someone, was waiting for a message all along? 21 minutes and 45 seconds. Across the globe, major observatories were notified. NASA, ESA, and other space agencies joined forces to focus their deep space listening arrays in the direction of Explorer 1. Meanwhile, classified discussions took place at the highest levels of government. But the response wasn't just being monitored on Earth. Explorer 1's instruments picked up something even more chilling. A second signal. This one wasn't structured like the first. It was longer, almost like a data stream, but interspersed with strange gaps, as if parts of the message were missing or being deliberately masked. And then, the spacecraft's instruments detected an anomaly in its own trajectory. Explorer 1 was slowing down. 22 minutes and 30 seconds. "That's impossible," a mission controller said, shaking his head. "There's nothing out there to cause drag. No gas clouds, no gravitational forces strong enough to affect its course. Something is interfering." "What if it's not a force?" Dr. Carter's voice was barely above a whisper. "What if it's an interaction?" The team scrambled to adjust Explorer 1's instruments, trying to compensate for the anomaly. But no matter what they did, the spacecraft continued to decelerate, subtly but undeniably. 23 minutes and 5 seconds. A deep chill settled over the room. Explorer 1 wasn't just detecting something. Something was detecting it. 23 minutes and 30 seconds. Then, without warning, the second signal stopped. The data stream cut off mid-transmission. For a moment, all was silent. The only sound in the control room was the steady hum of computers processing the incoming information. Then, a final transmission arrived. It was just one pulse. Louder. Sharper. Closer. And then, Explorer 1 went completely silent. 24 minutes. The spacecraft, humanity's farthest-reaching messenger, had stopped transmitting. And in its place, a new signal emerged. One that didn't come from Earth. The question was no longer whether we were alone. The question was, who or what had just found us?